All right, ladies and gents, I'm going to show you something pretty cool here in just a moment based on some of the things that we talked about yesterday. Okay, so I want you to pay real close attention as I go over these things. The reason is because what we're going to be looking at, for your homework deals with these things. So just pay real close attention. So anyways, what I'm going to do is I'm going to go ahead and use, I think it's my remote. Yeah, there you go. And I'm going to go to the web. And I'm going to go to a place called GeoGebra Classic. Okay, so I'm going to go to GeoGebra Classic. I'm going to bring something up. Now, there we go. And I didn't have to do that last one. Let's see. There you go. Okay, so clear things off. So in GeoGebra Classic, this program right here allows me to look at some geometric concepts on the computer. It's pretty cool. So let's take a look at this. So what I'm going to do here is I'm going to start off by forming a triangle here. And it doesn't matter what type of triangle I'm doing, but I have to come back and I have to touch on that last part right there. So you see that it's now solid. It's a triangle I can work with. Okay. And we didn't work with triangles yesterday, but what we talked about was if I go ahead and form a perpendicular bisector on a segment. So if I do the perpendicular bisector of segment AB, I just put that in. This is the perpendicular bisector of this segment right here, okay? Now, what did we say about any point along this segment? All right, now I'm gonna check real quick to make sure I'm on the, yeah, I'm good, okay. Any point along this perpendicular bisector is gonna be the same distance from point A as it is from point B, okay? So this point, what do we know about it? It's the same distance from point A and point B, okay? What I could do here is I could go ahead and move my triangle around, okay? Notice that that line segment doesn't move at all, okay? Well, it's because I'm not adjusting segment AB at all. But as soon as I start working with segment AB, oh boy, look what just happened here, okay? So again, perpendicular bisector, there's a right angle right here, and it's cutting this segment in half. So these two segments right here are equal, okay? Now, what I'm going to continue to do is I'm going to draw another perpendicular bisector in, okay? So I'll do this one of BC, all right? And so again, this length here and this length here are the exact same, and that's going to be a right angle right there, okay? Now, again, what do we know about any point along this perpendicular bisector? Well, it's the same distance from point C as it is from point B. If you can get the visual here, if I was to look at this point right here, what do we know about that point? It's the same distance from point C as it is point B, okay? And I can go ahead and, oh, I don't want to do that. Let's go back here. I can go ahead and just manipulate that. You can see that that segment's still going to be that right, oh, let go, that right angle there, and these two lengths are both the same, okay? Now my question to you guys would be this. What do we know about this segment, this point right here? That point is actually going to be the same distance from points B and C, but it's also going to be the same distance from points A and B, because this point right here is on both of these lines. So if any point on this line is the same distance from A and B, and any point on this line is the same distance from B and C, then the only point that they have in common has to be the same distance from all 3 points, okay? Now what's interesting about this is if I put in my third perpendicular bisector, that one right there, it intersects at the same point, okay? This point has a name. It's called the circumcenter, okay? You might want to write that down. This is the circumcenter, okay? And it's where the perpendicular bisectors come together, okay? So again, what is the circumcenter? Spelled C-I-R-C-U-M-C-E-N-T-E-R, circumcenter, okay? It's where the perpendicular bisectors in a triangle meet. Okay, again, write that down, where the perpendicular bisectors in a triangle meet. Now, again, that point is special because it's the same distance from all 3 of these vertices, all 3 of these points. So you might be thinking, well, how do we know that? How can I prove it to you? Well, take a look here. If I put a circle, starting with the center there, and work my way out to one of these vertices, you see that these points are all a radius distance from point D. Okay, and what's kind of cool with this program is I can kind of manipulate this. The circumcenter is moving in and out. I can make this a little bit smaller. So we can see that moving in and out. Okay, sometimes it's inside the circle, sometimes it's outside, whoop, and sometimes I can go on the other side. Okay, all right, but again, this is called the circumcenter. Point D is the circumcenter. And that's used to, now get this right here, guys, is used to circumscribe the circle about the triangle. Okay, so if you're circumscribing something about a polygon, okay, so circumscribe, you might want to write that down, C-I-R-C-U-M-S-C-R-I-B-E, circumscribe. If you're circumscribing a polygon, circle about a polygon, all of the vertices of that polygon are on the circle. So again, circumscribing means to put all the vertices of the polygon on the circle, okay? Another way to think about it is circumscribing is on the outside. Inscribing is on the inside. And I'll talk about inscribing here in a second, okay? So again, circumscribe the circle about the triangle there, okay? Now, I want to do another picture with you, and I'll go back to GeoGebra Classic. All right, and if I go ahead and do, again, another triangle for us, right there. Does not matter what the triangle looks like, okay? This time, we're going to take a look at the angle bisectors. So I'm going to go down here to angle bisector, and I'm going to actually trace angles A, B, C, okay? So if you look here, this line is cutting this angle in half. These two angles are the exact same. Now again, what do we say about any point along an angle bisector? Well, any point there is going to be the same distance from this side of the angle as it is from this side of the angle. So out here, the distance from over here to over here is the exact same length, okay? If I go ahead and do the same thing to another angle, okay, what you notice here is that this angle bisector, these two angles are the same measure, any point on this angle bisector is the same distance from this side of the angle as it is from this side of the angle, okay? Now, what do you think is true about this point right here? Well, kind of like the circumcenter, this is called the incenter, spelled just as it sounds, I-N-C-E-N-T-E-R, okay? The incenter, any point on this angle bisector is the same distance from these two sides. Any point along this angle bisector is the same distance from these two sides. So that point right there is actually the same distance from all three sides, okay? So I'm going to do one more angle bisector, and what you're going to notice here is that they're going to meet at the exact same point, okay? Now, I probably should have told you this on the previous one. This point, not only is it called the circumcenter for this graph right here, this problem, those lines are all what they call concurrent, okay? What do we call concurrent lines? 3 or more lines that intersect at a point, okay? Concurrent, C-O-N-C-U-R-R-E-N-T. So concurrent means 3 or more lines that intersect at a point, okay? So again, these lines, these angle bisectors, they're all concurrent at a point. And remember what we said, any point on any of these angle bisectors is the same distance from all three sides. So that point right there should be the same distance from all three sides of the triangle. Now, I have to do a little bit extra stuff here to show you why that's true. So what I'm going to do is I'm actually going to draw a perpendicular line. I think I want this one from a point to a line. So I'm going to do a perpendicular line from here to, and I'll do it, from that line, I meant that point. There we go, from that point to that line. Didn't work out like I wanted it to. Okay, so I think I need to get rid of one of these. What if I do and delete that? Yeah, there we go. Okay, so what I've done here is I've actually drawn a line that's perpendicular from this point to the side of the triangle. Okay, so this side right here, you can see the right angle right there. Okay, now what I'm going to do is I'm going to add a point right there. Oh, that's not what I wanted. Undo that. let's try the intersection. So the intersection of these two, that point right there. Okay, the reason why that's important is that's the shortest distance from point D to the side of the triangle. Okay, now that's going to tell me where I should put my circle. So if I do that, you notice there, it's touching all three sides. Okay, that point is the same distance from all three sides. And what you're going to notice as I move these points around, okay, it always remains touching the sides. So that point D is again called the incenter, where the angle bisectors meet. So the incenter, I-N-C-E-N-T-E-R, is where the angle bisectors of a triangle meet. Okay, they're concurrent at that point. And what that incenter allows us to do, it's the same distance from all three sides of the triangle. So the incenter is the same distance from all three sides of the triangle. Okay, and I can use that incenter to inscribe a circle. Inscribe. Okay, so there you go. You've got the incenter and the circumcenter. You've got circumscribing, you've got inscribing. Okay, some pretty technical terms there. You'll need to know those for your tests, so make sure you've got those down for me. Okay. Anyways, well, I hope that made sense. If it didn't, you can always look up some other videos on YouTube or come in and talk to me and we'll kind of get things figured out. Anyways, thanks for listening. Have a great day.